Okay, cooling tower. Cooling tower basically is a box with a fan with fill, water going across the fill. Now, most of you are familiar with cooling towers, what they look like. The fill looks like this. All right. Now, remember right at the beginning of the class yesterday, remember the slide that I showed? That showed the latent heat of vaporization. All right. Do you remember the BTU exchange? And remember, BTUs is what's doing the work. We're just changing, we're moving BTUs throughout the system, taking the BTUs from this room, sticking them into the water, which goes into the refrigerant, which goes to the water on the condenser side, which goes pumped out to the tower, goes into the hot deck, flows through the film, goes in the cold deck. Now what's going on when it goes through this is it is breaking that water up and spreading it out so that you've got the thinnest film of water that is practical. And what they're trying to do is promote evaporation. Remember, the latent heat of vaporization. How many BTUs was it? About 970 from when it changes state. It's a change of state that the work is being done. Latent heat of vaporization. A cooling tower does its work through evaporation. You evaporate better if you spread that water out and let that airflow get to it. All right? That's what it looks like. Definitions, just you're mixing air and water, bringing them into direct contact to transfer the heat from the water to the air. And again, it does that through evaporation. Now, you will have some water loss. You're going to have about 1% water loss through evaporation for every 10 degrees of temperature drop. And typically in our industry, our cooling towers have a 10-degree delta T. So rule of thumb, you're going to lose about 1% of your evaporation while you're circulating the water. In your formula sheet, I've given you some heat load formulas. You can take a look on the cooling tower side. However, understand when we're looking at the size of a chiller, we're not looking at it on the condenser side, are we? We're looking at it on the evaporator side typically, because that's what we're most interested in. If you want to apply that same formula to this side of the system, you can tell the performance of your tower. Now, if you look at the formula, it looks a little bit different from the formula that I passed out. However, it's basically the same. If you look at the BTU formula on your formula sheet, it matches that. If you look at the second formula on your sheet, your tons equals your delta T times your GPM divided by 24. That's assuming you're on the evaporator side. If you want to apply that formula, the math works the same as this formula. Instead of using a factor of 24, you use a factor of 30. Now that does not show on your sheet. If you want to just write a note beside that second formula, everything is the same. Just change the 24 to 30. That'll give you your performance of your cooling tower. Okay. In your cooling tower, you've got a hot deck and cold deck. Your hot deck is your tower where your water from your tower goes to the top of the tower. And it's either going to go into a trough with holes where it spills down and it's distributed along the fill, or Some designs will have it go into a pipe that goes to distribution arms, that goes to spray heads. Depends on the design of the tower. That is, the two is significant in that you don't really want to mix different types of towers. If you've got one that has the open hot deck, if you got two of them and you want to replace one of the two, it's best to keep them similar styles, similar designs. If you don't, you can get into some issues where when you cut the pump off, you can actually have some flooding back. Also in multiple tower cells. A lot of times you're pumping in water on one side and you're taking it out of another cell, and the cells have to be equalized. It's very important if you've got a cell equalization tube. Now that's generally going to be, let's say it's an 8-inch pipe that goes underneath and attaches to the basins of both cells. Now think about how deep is your tower sump? About this deep maybe? Okay, so you've got this much water going to a little valve, a butterfly valve, just for isolation purposes, a 90. So bottom line, you've got about this much water. How much pressure differential is that? So if you're taking water out of one cell, putting it in both cells, but you've got to equalize, you've got about this much water pressure. How much is that in PSI? Well, you're looking at about 1 PSI difference, because 2.3 feet of water column equals 1 PSIG. If you've just got 1 pound of pressure trying to push through that equalization tube, it's not a whole lot of force. And so when you're trying to pack 900 GPM through a tower and you're trying to equalize a basin, everything needs to be nice and clean. If you are cleaning a cooling tower and you're sitting there hosing it down, it's awful convenient if you've got that nice big hole right there and flush it down in there in the bottom of that pipe. Then over the years it starts building up, building up, building up. Then next thing you know, you're restricting the flow, which you've only got about 1 PSI of pressure trying to equalize, push that water down to the other side of the basin to equalize the levels. Now you start getting into where your one side is too low, and if it goes below your fill level, it can cause problems. Let me give you an example. Tower is a box. In that box, you've got a level of water. You got piping coming in from your chiller, dumping water into the top of your tower. Let's say you've got a hot deck, if it's that style. You got fill. Here's your fill. Your water's going to go down through the fill. You've got a big fan here drawing air this way. Your water is coming down this way. By the way, there's a name for this. It's called a crossflow. Crossflow tower. Now let's look at the fill. Let's look at the sump level and the air. This fill right here has to be beneath this water. If the water level is too low, then all of a sudden, instead of the air being drawn through the fill and out the top with your fan, air is going to take the path of least resistance, right? Unless you get that smart air that knows where to go, and I hadn't found that air yet. Most of that air is kind of dumb, takes the path of least resistance, and if the path of least resistance happens to be underneath this fill, because our water level's low, because I've got a 2-cell tower and my equalization line is partially plugged up, then now I've got some air going across here, but I've got some air bypassing. That cuts down on the ability of this tower to evaporate that water, move those BTUs out of the water, cooling it, send it